In this video lecture, I am going to discuss about the topic house wiring, industrial wiring, and materials of wiring. And also, we discuss the solving of simple AC circuit problem. First of all, we know about what is circuit, electric circuit. The wiring is electric circuit. What is wiring? Wiring is systematic laying of wires for the smooth flowing of electric current at different utility places with utmost safety and precautions. So this is the definition of wiring. The wiring may be classified into two. This domestic wiring, house wiring. Another one is power wiring, industrial wiring. And another types of wiring, cleat wiring, pattern wiring, casing, capping, conduit wiring. Under the category of pattern, PVC wiring, TRS or CTS wiring, lead sheath wiring under the category of pattern type. Similarly, under the category of conduit wiring, surface conduit and concealed conduit. So these are the different types of wiring. We see one by one. The conduit wiring, under the category of conduit wiring, surface conduit wiring, the concealed conduit wiring, surface conduit wiring. This surface conduit wiring, metal conduit wiring, and PVC conduit. Similarly, concealed conduit wiring, metal conductor and PVC conduit. Just a cleat wiring, the cleat with the two grooves, so cleat with the three grooves. These are two grooves, so three grooves. Three groove system, so two groove system. So it fit on the wall. The grooves are fit on the wall. A distance of half meter between two cleat. Between two cleat, half meters. That is the distance. Here, vulcanized Indian rubber wire is used. Vulcanized Indian rubber wire is used. In these systems are open system atmosphere. Now, this is the batten wiring. This is the batten wiring. Type of PVC wire, TRS wire, and lead sheath wire. This is the batten wiring. Right? The wooden casing, capping wiring. Wooden case. The case made up of wooden. So it fit on the wall with the help of screw. The help of this screw. Right? It will protect wiring from damage, the moisture, or any other abnormal conditions. For that purpose, providing wooden case for that kind of wiring. Similarly, PVC casing. Previous one is wooden casing. This is PVC casing. It become popular. Normally, everyone we are using PVC casing capping wiring. Lesser cost and easily fault identified, detected. The appearance of wiring is neat and good. So, surface conduit wiring. Surface conduit wiring. PVC or metallic conduit are used in this surface conduit wiring. PVC, VAR wire are used. PVC, either we may use PVC or VAR. VAR for vulcanized Indian rubber wires are used. Here the appearance is also good. It protects wire against mechanical damage and dust. Okay. So this is a surface conduit wiring. This is concealed conduit wiring. Yeah, concealed conduit wiring. PVC or metallic conduit are used conduit inside the wall. Appearance is also good. Protect against fire, dust, moisture, and any other mechanical damage. It requires less maintenance, less chance of fault, but cost is very high in this concealed conduit wiring. So the types of wiring already we discussed. PVC wire we use VAR, vulcanized Indian rubber, and CTS or TRS wire, weatherproof wire, lead cover wire, MICC wire. Right? It's a vulcanized rubber wire. This is vulcanized rubber wire. Vulcanized rubber. The three phase, the phase 1, phase 2, phase R, phase Y, phase B phase is a neutral wire. It's a weatherproof wire. It made waterproof by drooping it into waterproof compound. It's useful for service connections. Service connection, weatherproof wire in use. It's a lead cover wire. This is lead cover wire. It's a construction of lead cover wire. It's a lead covering, and another portion serving, and the insulation is the core. No effect of moisture on it is used any other place. They use under the UG cable system also they use for this lead cover layer. Right? It's a polyvinyl chloride layer. So dielectric strength is more. Dielectric strength means high insulation capability. High insulation capability is more in this PVC wire. Dielectric strength is more. The mechanical strength is also more. Long life to protect against flame and protect against oil and alkali, and cheap. Then compare them other than the types, the most economical one, right? So far we discussed the different types of wiring, the material used for wiring. Right? Now we go for single line diagram of electrical installation. Single line diagram of electrical installation. It's the energy meter. It's the incoming cable from the service connection, service line. The input of energy meter is incoming. And output of energy meter is going to cut out, and from cut out, consumer main switch, and after connecting cut out, from cut out to consumer main switch, and then goes to distribution box. Distribution box. From the distribution box, we may connect different. We can make different subcircuits for different connections. Right. So this is the single line diagram of electrical installation. The line diagram of service connection line, service line to main switch connections. The line, transmission line, is a service line. From the service line goes to energy meter, and energy meter to cutout, then cutout to distribution box. This distribution board, we may take different subcircuit connections. Subcircuit 1, subcircuit 2, another subcircuit for different rooms. Right? So for room 1, it's one terminal, the another terminal, one terminal from neutral, the another terminal from in phase. Similarly, in this subcircuit, from one terminal neutral, and another one is phase terminal. So all these phase terminals are connecting one common link. Similarly, all these neutral connections are connecting one common link. Right? It's the line diagram of service line to main switch connections. In this staircase wiring, we are using staircase wiring. How the connections are? It's one lamp. The one lamp is going to be controlled by two switches. This is staircase wiring. Only one lamp controlled by two switches. Right? So this is the neutral terminal directly connected to the lamp 1. The another terminal from switch S2, and then goes to switch S1. So in this staircase wiring, two-way switches are there. This is two-way. These two-way switches are used for such kind of staircase wiring. Only one load. The load, there may be one lamp or one fan, right? So one load can be controlled by two switches. In this switch for two-way connections. Yeah, two-way switch for staircase wiring. Now, how the staircase wiring on? Neutral one. Now, here S1 and S2. S1 are like in this question, S2 both are connected in this question. Now switches circuit is on. Now lamp L1 is on. But we can change this switch any one connection of S1 or S2. The switch L1 is off. Okay? So this is the operation of staircase wiring. If L1 is on, S1 and S2 are connecting in this position. So any one of S1 or S2 may change. So lamp L1 is off. Right? So this is the operation of staircase wiring. Right. Now we see the single phase circuits. So far we discussed about the house wiring and the power wiring. One example of house wiring we discussed. Another example discuss staircase wiring. Right. Now single phase circuits. In any AC circuit may contain any one or two or all of the following three circuit elements. So what are all the circuit elements? Are resistance, inductance, capacitance, RLC. Symbol of resistance R, symbol of inductance L, symbol of inductance capacitance. These three elements are contains AC circuits. Now AC through pure resistance. This is the circuit contain pure resistance. So the resistance is the property of material by which it opposes the flow of current. And at the same time convert entire power into heat. If resistance is connected in the circuit, right? The voltage V is equal to Vm sin omega t. V is equal to voltage applied to the pure resistance circuit. I, current flowing through resistance R. Indicates there is no phase angle between voltage and current. No phase angle between voltage and current, represented by the phase angle. The waveforms, the voltage waveform, this is the current waveform. The voltage waveform V is equal to Vm sin omega t. Current waveform I is equal to Im sin omega t. Both are in phase. Voltage and the currents are in phase. No, there is no phase angle between them. Now we can calculate power. Instantaneous power. P is equal to V into I. Vm sin omega t. Then I value Im sin omega t. Vm Im sin square omega t. Simplification of this. Vm Im 1 minus cos 2 omega t by 2. Finally, the average power is Vm Im by 2. Right? Now the average value of power Vm by root 2, Im by root 2 is the RMS value. Any kind of AC circuits, you can calculate RMS value from the average value. Right? So from the average value, the RMS power VRMS, Vm by root 2, IRMS, Im by root 2. Then inductance, pure inductance. Same coil connected across the supply, AC supply. The inductance is the voltage waveform, the current waveform. The voltage waveform, current waveform. Here, voltage vector V lags the current vector I, the angle 90 degree. Right? So here, the voltage vector is Vm sin omega t. The current vector lagging behind by 90 degree. So Vm sin omega t, Im sin omega t minus pi by 2. Pi by 2 is 90 degree. So Vm Im sin omega t sin omega t minus theta is minus cos omega t. So the average power Vm Im by 2 sin 2 omega t. So sin 2 omega t value is 0. The average power is 0. Right? So an example, solved example. So far we discussed resistance, inductance connected in the circuit. For example, a coil having a resistance of 6 ohm and an inductor of 0.03 Henry. The inductance value, unit of inductance is Henry, is connected across 100 volts AC supply, 50 hertz, 100 volt, 50 hertz AC supply. Calculate current, phase angle between the current and voltage, power factor and power. First, we have to calculate the current value, the AC circuit. Two elements are the resistance and the inductance, R and L. So how can calculate current using this Ohm's law, V by Z? V voltage, input voltage, Z impedance, right? The impedance, how can we calculate impedance using this formula? Square root of R square plus XL square. Resistance in the circuit, XL. Inductive reactance in the circuit. So the inductive reactance XL is equal to omega into L. The omega value, omega is equal to 2 pi F into L. F is the supply frequency, L inductance, all these values are there. And after substituting this value, you can get the XL value. Similarly, you can also calculate the inductance. So the voltage, supply voltage is 100 voltage. Already we have the value 100 volts. And the impedance we calculated, and V by Z, so the current is 8.96 ampere. Similarly, you can calculate power factor, cos phi is equal to R by Z. Z value calculated, R value already again. So phi is equal to cos inverse of, so R value 6, then impedance Z value 11.6. And after substituting this value, calculate the phi value, and finally cos value also. So cos phi is equal to 0.537 lagging. Why? You can write here lagging because inductance is also connected there. Okay? Using inductance, you can get the power factor is lagging value. Right. Now, I'll calculate power. With the power calculation of power, Pi cos phi, voltage 100 already given, and current calculated, power factor cos phi calculated. So by substituting these values in the formula, calculate power value. Okay. So this is the example of simple AC circuit. AC circuits contain resistance and inductance. Right? Thank you.